we've been to the edge of our solar system. We've ranked 10 places in our own backyard that would kill you instantly, and 10 worlds around other stars that make those look welcoming. But here's something the series hasn't addressed yet. Some of the most extreme, most violent, most genuinely bizarre environments in the known universe aren't planets at all. They're moons, worlds orbiting worlds. And some of them are hiding things that still keep scientists up at night. Not just because of how hostile they are, but because of what might be alive inside them. Today, we're counting down the 10 most extreme moons in the solar system and exactly what makes each one unlike anything else we've ever found. This is the 5th and final video in our Space Will Kill You series. We've covered what kills you up in space, what space can do to you right here on Earth, the deadliest places in our solar system, and the most lethal exoplanets ever discovered. Now, we're bringing it home and finishing on the worlds closest to us that we still barely understand. Subscribe if you're new, and let's count down from 10. Number 10, Hyperion, one of Saturn's smaller moons, and the first entry on this list that's extreme, for a reason you might not expect. Hyperion doesn't rotate in any stable, predictable way. Most moons are tidally locked, keeping the same face toward their planet forever. Hyperion tumbles, chaotically, unpredictably, its rotation axis shifting every few weeks in a pattern so irregular that scientists call it genuinely chaotic motion. You cannot predict which way Hyperion will be oriented at any given future moment. The math simply doesn't converge. Its surface is covered in deep, steep-walled pits that give it the appearance of a cosmic sponge, carved out by impacts into material so porous and low density that the debris just sinks in rather than scattering. It isn't the deadliest moon on this list, but it opens it because it's a reminder that even the physics of rotation isn't something you can take for granted out here. Number 9, Miranda, a small moon of Uranus, and one of the most geologically bizarre objects in our entire solar system. Miranda looks like it was smashed apart and reassembled by someone who lost the instructions. Its surface is a patchwork of completely different terrain types sitting directly next to each other. Ancient cratered plains abruptly meeting grooved canyon systems that have no business being adjacent. But Miranda's defining feature is Verona Rupes, a cliff face approximately 12 miles or 20 kilometers high, the tallest known cliff in the solar system. For context, that's more than 10 times the height of the Grand Canyon's walls. In Miranda's low gravity, roughly 1% of Earth's, if you fell off the top, it would take roughly 12 minutes to reach the bottom. That's a long time to think about what went wrong. Number 8, Charon, the largest of Pluto's 5 moons, and one of the strangest gravitational relationships in the solar system. Charon is so large relative to Pluto, roughly half its diameter and about an eighth of its mass, that the two don't orbit each other in the typical planet and moon way. Instead, both bodies orbit a point in the space between them, making Charon less a moon and more a co-dwarf in a binary system. Both are tidally locked to each other, meaning the same faces are always pointing inward. Pluto and Charon forever staring at one another across a gap of roughly 12,000 miles. But what New Horizons revealed about Charon's surface in 2015 was genuinely startling. A rust-red polar cap stained by complex organic compounds called tholins, and a canyon system stretching nearly 4 times the length of the Grand Canyon. Charon is not a dead rock. It's a geologically active world, on the edge of the solar system, in the dark, doing things we didn't think small worlds could still do. Number 7, Triton, Neptune's largest moon, which made a brief appearance in our solar system video and earns a full entry here. Triton is one of the coldest objects ever measured in our solar system. Surface temperatures hover around 235 degrees below 0 Celsius, cold enough for nitrogen itself to freeze solid and coat the ground like snow. But the geysers are what make Triton genuinely haunting. Nitrogen heated just barely by sunlight beneath Triton's translucent ice crust builds enough pressure to erupt in dark plumes that shoot 5 miles upward before being swept downwind, leaving dark streaks across the southern polar cap that look, from orbit, like scorch marks. Here's the part that makes Triton unique. It orbits Neptune backwards, against the direction of Neptune's own rotation. No large moon in the solar system does this. That retrograde orbit is almost certainly a sign Triton didn't form here. It was likely captured from the Kuiper Belt long ago. And that backwards orbit is doomed. Neptune's gravity is slowly, relentlessly pulling Triton inward. In roughly 3.5 billion years, it will be torn apart, shredded into a new ring system around the planet that captured it. Triton is not just extreme, it's temporary. Number 6, Titan, Saturn's largest moon and the only moon in the solar system with a thick atmosphere and stable liquid on its surface. And here's why Titan is so deeply unsettling. It's familiar. It has rivers, lakes, deltas, rain, seasons, weather systems. It has a full hydrological cycle, the same kind of cycle that shaped Earth's oceans and continents, running on the exact same physics. The problem is the chemistry. Titan's liquid is methane. Its rain is methane. Its lakes, the largest of which, Kraken Mare, is larger than the Caspian Sea, are pools of liquid methane and ethane, the compounds we burn as natural gas. Surface temperatures sit at 290 degrees below 0 Fahrenheit. Step outside without protection and you freeze solid beside a lake of liquid fuel. Under an orange sky so thick with nitrogen haze, you'd barely see the sun. NASA's Dragonfly mission is heading there in the early 2030s. A rotorcraft lander designed to fly between landing sites across Titan's surface. What it might find is one of the most open questions in planetary science. Titan's chemistry is so complex, so organic, that some researchers believe it could be hosting a form of life built entirely without water. Not life as we know it. Something stranger. Number 5, Enceladus, a moon barely 300 miles across that has become one of the most scientifically significant objects in the entire solar system. Near its south pole, 4 parallel cracks in its ice crust, nicknamed the Tiger Stripes, spray over 100 geysers of water vapor and ice particles directly into space, continuously, feeding one of Saturn's rings entirely from Enceladus's own interior. When NASA's Cassini spacecraft flew through those plumes, it detected something extraordinary: complex organic molecules, molecular hydrogen, silica particles that could only form in hot water reacting with rock. All of it pointing to a global ocean of liquid water beneath the ice, kept warm by tidal heating from Saturn's gravity, with hydrothermal activity on the ocean floor. On Earth, those same conditions: warm water, rock, organics, chemistry, are exactly where some of the earliest life is thought to have appeared. Enceladus is deadly at its surface, 320 degrees below zero, active geyser vents, the vacuum of space opening up through every fissure. But below the ice, in the dark, there is a warm, salty, chemically active ocean that has been sitting there for potentially billions of years. If life exists anywhere else in our solar system, Enceladus is one of the best places to look. Number 4, Europa, Jupiter's most scientifically tantalizing moon, and one of the most hostile surfaces in the solar system at the same time. Europa's ice shell is cracked and re-cracked in every direction by the tidal forces of Jupiter and its neighboring moons, flexing the moon's interior, driving a subsurface ocean of liquid water, estimated to be roughly twice the total volume of all of Earth's oceans combined, beneath a shell of ice anywhere from 10 to 30 kilometers thick. The surface looks almost pristine, smooth, young, very few craters, because the ice constantly resurfaces itself. It is beautiful, and it will kill you within hours. Europa sits deep inside Jupiter's radiation belts, absorbing over 500 rem of radiation daily, a lethal dose for an unshielded human in less than 24 hours. Whatever mission eventually reaches Europa's ocean, drilling through kilometers of ice while surviving that radiation bombardment, will be one of the most complex engineering challenges in human history. But the potential payoff is staggering. An ocean that has existed for billions of years, kept liquid, warm enough at its floor for hydrothermal chemistry, potentially containing enough chemical energy to sustain life. NASA's Europa Clipper spacecraft launched in 2024 and is currently en route. We may have answers within this decade. Number 3, Io, Jupiter's innermost large moon, and the most volcanically active body in the entire known solar system. Not just our solar system, anywhere we've ever looked. Io is caught in a gravitational tug-of-war between Jupiter and the other large moons, and that constant flexing generates so much internal friction that its interior is in a state of permanent, violent meltdown. Over 400 active volcanoes cover its surface. The largest, Pele, produces a sulfurous plume that rises 300 miles into space. Lava fountains here reach temperatures exceeding 2,400 degrees Fahrenheit, hotter than virtually any volcanic eruption ever recorded on Earth. The surface is so constantly repaved by fresh lava flows that impact craters barely have time to form before they're buried. Io's surface is simultaneously everywhere and nowhere, always being destroyed and replaced, a world that is literally turning itself inside out, continuously. And that's before you factor in the radiation, sitting inside Jupiter's radiation belts, closer than even Europa. Io absorbs roughly 3,600 rem of radiation every day, nearly 7 times Europa's already lethal dose. Io would kill you from orbit if somehow you landed. The volcanoes, the sulfur dioxide atmosphere, and the radiation would be competing to finish the job first. There is no ranking of danger on Io. It is simply all of them at once. Number 2, our own moon. And before anyone argues with this placement, hear it out. We've sent 12 humans to walk on the moon. That's 12 people who survived its surface with 1960s and 1970s technology and came home, which tells you exactly how extreme it is. Even getting that far required some of the most complex engineering in human history. The moon has no atmosphere, none, which means no protection from micrometeorites, no buffer against radiation, and temperature swings from 260 degrees Fahrenheit in direct sunlight to nearly 300 below zero in shadow. Those shadows can be reached within a few steps. Lunar dust, regolith, is made of sharp, jagged, electrostatically charged particles that stick to everything, clog equipment, scratch visors, and if inhaled, can cause serious lung damage. The lunar night lasts approximately 2 weeks, dropping temperatures low enough to destroy unheated equipment, and every Apollo mission operated in the knowledge that a single suit breach, a failed ascent engine, or a miscalculated trajectory meant staying forever. The moon is number 2 on this list, not because it's the most exotic, but because it's the one we've actually experienced. And it nearly ended multiple missions anyway. Familiarity isn't the same as safety. The moon is still trying. Number 1, Ganymede, the largest moon in the solar system, larger than the planet Mercury, and the only moon anywhere we have ever found that generates its own magnetic field. That alone makes Ganymede unique. Every other moon is a passive object, shaped by the forces around it. Ganymede has its own field, generated by a churning iron core, creating a miniature magnetosphere that carves out auroral zones near its poles, real, glowing auroras on a moon, driven by its own internal dynamo. But what places Ganymede at the top of this list isn't just what's on its surface. In 2015, scientists confirmed that Ganymede harbors a massive subsurface ocean, a saltwater ocean estimated to contain more water than all of Earth's oceans combined, trapped between layers of ice deep beneath the surface. And because of Ganymede's magnetic field interacting with Jupiter's vastly more powerful field, that ocean is being gently, constantly stirred, creating conditions that could, over billions of years, support chemistry. The ESA's JUICE mission, Jupiter Icy Moons Explorer, launched in 2023 and will enter orbit around Ganymede in 2034, making it the first spacecraft ever to orbit a moon other than our own. What it finds there may change how we think about where in the universe life can exist. Ganymede is number 1 on this list, not because it will kill you fastest. It's number 1 because of what it represents. A world larger than a planet, with its own magnetic field, its own geology, its own ocean, in our own solar system, 40 minutes of light travel away, that we have barely begun to understand. 5 videos, from the inside of a cracking spacesuit to the most extreme moons in our solar system, and a few detours to exoplanets made of iron rain and glass along the way. Here's the thing that stays with you after all of it. Space is not indifferent to us. It's not trying to kill us exactly. It just operates by rules that we were never built for. And our survival, up there or down here, depends entirely on how well we understand those rules and prepare for them. Which brings us to where this series is going next, because we haven't actually answered the practical question. If space reaches down and tries to kill you on the ground, a falling satellite, a coronal mass ejection, an incoming rock, what do you actually do? The next series is a survival guide. What to do when a geomagnetic storm hits the grid. How to respond to a confirmed asteroid impact warning. What a Carrington-level solar event looks like from the ground. And how to be the person who makes it through. Real scenarios, real science, real preparation. Which moon from today's list surprised you the most? Let me know in the comments. Subscribe so you don't miss the first episode of the new series, and I'll see you in the next one.